Start.
Yeah, okay. So, good evening, everyone. My name is Akshay, and today we'll be discussing on the some of the questions that were asked in GATE exam based on calculus and optimization part of the mathematics course. So, before going to the actual content, uh, these are the various courses offered by iitians classes. You can have GATE online coaching, you have target GATE course, online test series is there, and distance learning program is also there. So interested, and we have various streams here. So interested students can explore more, and it will be beneficial for your not only GATE but other competitive exams also. So yeah, today we'll discuss about the GATE paper, which was this year 2024, recently conducted for the stream data science and artificial intelligence. And we'll be discussing one section of the maths paper today, which is dealing with the calculus and optimization part. So there were total 5 questions from this section, and total marks that one could have scored with answering all the questions from this part, around 8 marks, which is quite significant if you compare the total number of marks in the GATE exam. And yeah, so we'll start. So there are like 5 questions. So first is regarding the basic nature of this minimum maximum. So I'll read out the question first, and maybe then we can think about solving it. So one second. Yeah, so it is the 15th question, and for any twice differentiable function. So this is your first hint. So the question itself mentions that the function f, which is the function of interest in this question, is twice differentiable. So I hope you understand what twice differentiable means. It means that first derivative, which is f dash of x, and the second derivative, which is f double dash x, exists. So when any function is said to be twice differentiable, that inherently implies that first derivative also exists, and the second derivative also exists. In other words, if it is mentioned that the function is nth time differentiable, that means nth differentiable or different, what do you call that? That order, nth order derivative exists, and all the orders below that also exist. So that is one thing you should understand when such notation is given. And this function maps from R to R, where R is a set of real numbers. So that is one hint. In this question, it is not relevant, but sometimes it helps in eliminating some options. And at some x star, which is also a real number, your first derivative goes to 0, and second derivative is positive or greater than 0. Then what is the nature of function f at x star? That is the question. And you have 4 options. A option and B option are suggesting it is a minimum. C and D suggesting it is a maximum. And amongst those also, A option is local minimum, B option is global minimum. So uh, uh, before going to the matter of the question, local minimum means, uh, see, this function is defined over the all set of real numbers, right? But if you take a small subset of that number line, and if you find a minima there or maxima there, that that minima or maxima is called as local minima or maxima, because it is defined on a certain subset of the whole, uh, x, or in this case x, but whole argument of the function. And global minimum is called as global, as the name suggests. It implies that for all the values, or in this case for all the real numbers, that x star, which is global minima or maxima, f dash of x star will be 0, and f double dash of x will be greater than 0 or less than 0, depending on the minima. But it will be a global minima, and it is a uh, typically global minima is a unique minima. In some special cases, there can be two global minima, but they'll have same value. That is very rare. But as the global suggests, the keyword global suggests, it is a minimum where it is the absolute minimum for all the x values that the function can take. So, having clarified these basic things, we'll just talk about the solution for this problem. So, here it is mentioned that uh, at sorry, at x star equal to x, I think 1 second. Mm, I think there is a delay. 1 second. Yeah. So at x equal to okay. 1 second. Hmm. Yeah. So at x equal to x star, your f x star goes to 0. That implies x star is a stationary point. So uh, this is the definition of a stationary point. Basically, wherever the first derivative goes to 0, it is called a stationary point. You'll come across some cases where it is called as critical point also. Both are fine, but let's go with the one nomenclature. And second derivative at x star is greater than 0. So by definition, this means uh, the function f of x at x star will be having minima there. So at x star uh, represents a minimum. But now the question is, I hope this is clear, because uh, uh, you must have studied that whenever the second derivative is greater than 0, that represents a minimum, and wherever the second derivative is less than 0, that represents a maximum. But now the question is whether it's a global minimum or local minimum. Now, in this question, uh, nothing is mentioned about the nature of the function f of x. Uh, so, if nothing is mentioned, we cannot assume, or we don't have any other information to go on. What I mean to say here is, let's say, let's say it is given that f of f of x is a strictly convex function, then we can conclude that fx star is a global minimum. And but this was not mentioned in the question. And what I mean by convex function is, we just use a new slide for this. Uh, so basically, convex function is a special class of function uh, where you know. Uh, so mathematically, it is defined as if you draw, let's say you take any 2 points on this function. For example, if I can draw, 1 second. So let's say uh, we have a function like this. This is the x and y axis. So let's say this is our typical uh, two-dimensional function, and let's say the function looks like this. Maybe we don't know the nature of it, but it's look like this, and this is a twice differentiable function by the looks of it. And if you join any 2 points, let's say these 2 points, if you join on this function, if all the points uh, which are shown by black dashes here, if all the points on that function lie below the line connecting the two endpoints, then the function is uh, considered as a convex function. And there is a theorem which will not prove here, but the theorem says that if any function is a convex function like this, it will have a global minima wherever f dash of x star goes to 0. But since so this is a convex function. Okay, but okay, 1 second. uh, I have to delete this. Okay, sorry for that. So if it is a convex function, it will satisfy this property. And if it is a convex function, then we can say that wherever f star x is 0, that is the global minimum. But in this question, since uh, no additional information regarding the nature of the f of x is provided, we can only conclude that f x star is a local minimum. Okay, I hope you get my point here. So this was regarding the question. I hope you understood what I mean by convex function and all. So in future, if somebody gives you a question in which they mention that it was a convex function, then you can click the option which says global minima. Otherwise, you can only say local minima with surety. Okay, so we'll go to the next question. So yeah, basically in this question, the correct option is local minimum, option A. We'll go to the next question now. Yeah, so this is 33rd question in the paper, and here also a function which is, okay, I should be careful about the colors. Okay, I'll use for this. So here again, a function which is mapping R to R is given, and the exact nature of function is also given. It is 1 divided by 1 plus e to the power minus x. E represents exponential function, and it is mentioned that the value of derivative of f at x where fx is 0 is. So first of all, the language is slightly tricky here. So they are asking for value of derivative of f at x. So that means they are asking for f dash of x, but where? They have not mentioned at what x. So they are mentioning that where fx is equal to uh, 0.4. So in this question, it's slightly tricky because uh, they have not directly given you the x where you want to find the derivative. You have to first solve this equation to get that x, and once you get that x, then you can put that, and then you get the first derivative. And you keep in mind that you have to round it off till 2 decimal places. This is also important because this is a data entry type question, and you should not be overconfident in these cases. And yeah, this R is the universal notation of set of real numbers. So now, first we have to find x where f of x is 0.4. So now to do that, we need to solve this equation. Now see, f of x is 0.4, right? So that means, 1 second. So we have, okay, I'll use black color for solution going forward. So we have f of x, which is 1 by 1 plus e to the power minus x. Correct? Then what is asked is, uh, yeah. So uh, first we need to find x equal to, let's say, x star. We'll use the same notation where f of x is 0.4, and yeah, here it should be x star since we are assuming some uh, you know some token symbol. 1 second, I think I should just rewrite that. So uh, f of x star equal to 0.4. Okay, so now use the equation, use the function definition. So this also equals that 1 by 1 plus e to the power minus x star will be 0.4. Therefore, you can say, you can invert this, and you'll get 1 plus e to the power minus x star equal to 1 by zero point 0.4, that is 2.5. Therefore, e to the power minus x is 1.5. And then you can take, log on both sides, and you can find x. So can do that. Therefore, ln of x. So this will become minus x. This will become natural log of 1.5. And you can put the minus sign over to the other side and there you will get x. So something like this. So at this x star, your f of x gives you the value of 0.4, correct? So now half of the part is done. But see, in this question, it was not asked that what is the x star. What is asked is what is the f of x star. Sorry, f dash of x star. So to do that, first we need to find what is the derivative of this function. So f of x is 1 by 1 plus e to the power minus x. Therefore, okay. Therefore, f dash of x, we have to use uh, this is u by v kind of function. So first we have to take that chain rule we have to use here essentially. So this will be first minus 1 by 1 plus e to the power minus x whole square. Now we have to take the derivative of 1 plus e to the power minus x according to the chain rule of differentiation. 1 is constant, so derivation is 0. So e to the power minus x, its derivative is e to the power minus x itself. And then derivative of minus 1. So minus x, that will be minus 1. So therefore, if you simplify further, this minus into minus will become plus. So you'll have e to the power minus x divided by 1 plus e to the power minus x whole square. So this is what we need to find. We need to find f dash of x star, where x star is minus ln 1.5. But see, there is a trick here. You don't need to do all the calculations. See, if you name this result as equation 1, you know that e to the power minus x star is 1.5. And that's all you need, right? Because here you need e to the power minus x only. So we can use e to the power minus x star equal to, what is it? 1.5. So if you do that, then f dash at x star, which is the final objective of this question, which is nothing but e to the power minus x. So I'll just write it down here. One second. Yeah, e to the power minus x star divided by 1 plus e to the power minus x star whole square. And e to the power is 1.5 divided by 2.5 whole square. So you can use any calculator or any simple calculation also you can do, dividing by 5 on both sides. So that will be 3 by 5 into 2.5. So if you do that calculation, you should end up at 0.24. I have done this calculation and this is the correct value. So this is your solution. And they have, one second. Yeah, and in the question it was asked that you should put up to 2 decimal places, so therefore 0.24. So in this question, see, if you blindly calculate x and then you put that value in f dash of x, so that would take a lot of time. So sometimes you have to use a little bit of common sense, and then you can solve this type of questions easily. uh, here the trick was, instead of using direct x star, if you can use e to the power minus x star, then you could have easily solved this question with lesser time and lesser calculation requirements. Okay, so that is regarding this. So we'll go to the next question. Yeah, so this is question number 37, and it is also testing your knowledge of continuity, differentiability of a function in, let's say, a defined finite interval. So the question is, again, this is a function mapping R to R. That means it takes real number as arguments and gives output as a real number. And this function is not, uniformly defined over all x values. So for certain x values which are less than -2, it is minus x. When x value belongs to -2 to +2, it is a quadratic function of this nature, ax square plus bx plus c. When x is greater than 2, it assumes a linear form of f of x equal to x. These close brackets indicate that, at x equal to 2, function is quadratic and not x equal to f of x equal to x. So you should know, or you should be, careful about the close brackets also in some cases. Then this is the definition of this function, and they are asking that which one of the following choices. So they have boldened it, but in any way you have to pay attention to such tricks or such hints. So in this question, there will be only one correct answer. There are not multiple correct answers. And we have to find the values of A, B, C, which are the unknowns in the quadratic equation given in this middle definition of middle row of the definition, that make function f continuous and differentiable. So this is the main part of the question, which is given at the end. That we need to find a, b, c, which are unknown constants, such that f of x becomes continuous and differentiable all over the values of x. So you have four options here, and you cannot infer anything from the options because all of them are different. Sometimes what happens, if two options are similar, you could narrow it down to that and maybe save your time, but in this case it's not possible. So we have to solve this question the hard way or the conventional way. So now, okay, 1 second. We know for a function to be continuous at, let's say, x equal to x star, uh, maybe let's say this function is f of x. I should have written it here, but let's say, or maybe I can write it 1 second. F of x to be continuous at x star. Its left hand limit should be equal to the right hand limit, and that should be equal to the actual value of the function at x star. And what I mean by that, in terms of mathematical notations, you write it in this way: x approaching x star from uh, left hand side or right hand side, whichever convention you want to choose. That limit must be equal to the limit where you approach x star from another side, which is x star minus f of x, and these values must be equal to the f of x star. So when this equality is strictly satisfied, then only you can say that function f of x is continuous at x equal to x star. And we have to use this definition of continuity for our problem. So yeah, so our function is like this. So what we can do, we can check the continuity at -2 and +2, because uh, at other points function is continuous. The quadratic function will always be continuous, and f of x equal to -x and f of x equal to +x, these functions are also continuous. So we have to check the limit at uh, first checking the limit at x equal to 2. In this case, the necessary condition for f to be continuous, for f of x to be continuous at x equal to 2, it should satisfy the limit definition. Let's say you're approaching 2 from the right hand side, because that is the uh, you know that is the side from where you are coming, from infinity to 2. F of x should be equal to f of 2. So now what is the limit f of 2? So that means it is nothing but x. So you have to put 2, because the function is f of x is equal to x when you approach from 2. And what is f of 2? F of 2 is nothing but the quadratic equation, which is given by this formula. So here also you have to put 2. So it will be a into 4 plus b into 2 plus c. So that is your equation number 1. And now you check the same thing at x equal to -2. So similarly, at x equal to -2, limit it's tending to -2 and we are approaching from the negative side. F of x should be equal to f of -2. Okay. Now what is the value of f of x at -2? That is again given by the quadratic function. So that will be a into x square, so that will be 4, plus b into x, that is -2, plus c is again constant. So this is 4a minus 2b plus c. And what is the limit? It is -x. So if you put -2 in -x, that becomes -x, and x is -2. Therefore it is 2 equal to 4a minus 2b plus c. So this is your second equation. Now if you compare equation 1 and 2, so here I'll write here only, and equation 1 is 2 equal to 4a plus 2b plus c. So now you just look at the two equations, and from here itself you can deduct that this equation will only be having a solution when b is equal to 0, because otherwise these two equations cannot satisfy uh, uniqueness criteria, right? In other words, if you add or if you subtract 1 from 2, then you will have 0 equal to 4b. That means b equal to 0. So that is the first piece of the puzzle. Now we don't have much to go on here with only continuity. So we need to take the help of differentiability. So uh, yeah. So for f of x to be differentiable at some point x equal to x star, its right hand derivative must be equal to the left hand derivative. Here there is, you know, the differentiability goes to the uh, first order derivative for the f of x. Continuity deals with the f of x, but the differentiability deals with the first order. And right hand derivative, so let's say at x equal to 2, your right hand derivative is you're approaching from the infinity to 2, so that means your f of x is 2. And if you take the derivative of f of x, so that will be derivative of x equal to the derivative of uh, left hand derivative is you are approaching the quadratic function. From quadratic function you are going to 2. So in that case it will be ax square plus bx plus c. So this is 1 equal to 2ax plus b. So this is your third equation. And at x equal to minus 2, you apply the same logic. Here your function will be minus 2, right? Because you are approaching from the actually here the this will change because left and right derivative definition changes here. So here right hand derivative will be your quadratic equation derivative. So that will be ax square plus 2b plus c. And one second. Yeah, and your other derivative will be because it is minus x at x equal to minus 2. So from here you get same, this is 2ax plus b equal to minus 1. So this is your equation number 4. Yeah. And actually you can put x value itself here. So rather than making it lengthy, I'll simplify here only. So here you have to put x equal to 2. So that gives you 4a plus b equal to 1. This is your third equation. And when you put x equal to minus 2 in this equation, you get minus 4a plus b equal to minus 1. So this is your fourth equation. So from here, in see, b is already 0 because that we got from the continuity equation, right? So that means therefore you have 4a equal to 1. That gives you a equal to 1 by 4. And now what about b? So see, uh, let's say this equation 2. So if you put b equal to 0, therefore you have 2 equal to 4a plus c, right? So continuity equation is still helpful. So now you have this condition which is 2 equal to 4a plus c. Now you put a equal to 1 by 2. I'll use the next slide. Okay, one second, it is loading. So now here we know that it is loading. So we'll wait for some time. Yeah. So we know that a is equal to 1 by 4 and 4a plus c is equal to 2. So therefore c turns out to be 1. Okay. So this is your solution. So a equal to 1 by 4 comma b equal to 0, comma c equal to 1. So this is your answer. And we'll just make sure which option was that. So that was option A. So this is your answer. Okay. So I hope continuity and differentiability definitions and use of them to solve this question is clear. So then we'll go to the next question. Okay, so here again there is a function which is mapping R to R, and the definition of function or the nature of the function itself is given here. It is a fourth order function, so fourth degree function. We can call it as a uh, quadratic, not quadratic, quadruple. I don't know. Sorry. So it is a fourth degree function, and it is asked that which of the statements is or are true. So it can be a multiple correct option question, and they are talking about. For some reason. Okay, so I'll repeat. So there is a function which is mapping R to R, and it's a fourth degree function which is indicated by x power 4 by 4 term, and uh, there are it is a multiple choice or multiple option correct question. Dinesh sir, am I audible? I was disconnected in between because of some network.
Yes, you are audible. It is a MSQ question, multiple select.
Okay, okay, okay. So there are four options, and we have to check each option. So before that, since this question is asking about local maximum, local minimum, it's always better to take the derivative, and then you find the stationary points, and then you check the second differential condition. So uh, we have f of x as x power 4 by 4 minus 2x cubed by 3 minus 3x squared by 2 plus 1. So we can take differentiation first order derivative of this, that will be x cube, because 4x cubed by 4 will get cancelled. Here also it will be 2x square because 3 will get cancelled. Here also it will be 3x and 1 will go to 0. And you can further simplify this. You can take x common, then there will be x square minus 2x minus 3. And again you can further simplify this. You will have minus 3 and plus 1. So uh, when f dash of x equal to 0, I should not say when, for f dash of equal to 0, we have x equal to 0, x equal to 3, and x equal to minus 1 as the stationary points. So now you can see that in these options, they were mentioning 0, 3, minus 1, right? If you check the ABC option. So that should give you confidence that you are on the right track. You are also getting something like this. Now you have to decide whether it's maximum or minimum, and for that you need to take the second order derivative. So if I do that, if I take the second order derivative, then x cube becomes 3x square, 2x becomes 4x, 2x square, and this minus 3x becomes 3. So now we have to check at each stationary point what is the value of f double dash x. So I'll write f double dash x here again for clarity. So that is 3x square minus 4x minus 3. So we'll check at x equal to 0, because that is one of the stationary points. At x equal to 0, what is the f double dash? It is minus 3, right? Because all the x term will go to 0. That is less than 0. So by definition, this means it is a local maximum. Okay. Then at x equal to 3, what is the value of second derivative? It is 27 minus 12 minus 3, which is 15 minus 3, 12. So 12 is greater than 0. That implies it is local minimum. Okay. Then you check at x equal to minus 1. What is the second derivative? That turns out to be 3 plus 4 minus 3, which is 4, which is greater than 0, and by definition this implies that it is a local minimum. Therefore, you have minimum at 3 and minus 1 and maximum at 0. So if you check the options, the first option is correct because 0 is maximum and 3 and minus 1 are minimum. So second option is correct. Fourth option is wrong. It says maximum, it is minimum. And fifth option by contradiction only. If A is correct, then D has to be wrong. So A and B are correct. So that is the solution. And you can use, this online free website is there. Desmos graph plotter is there, and just if you are curious, you can go and put the function there. It's a free resource, and then you can plot it. I have done that, and it looks something like this. I mean, my drawing is not up to the scale, so it's just a schematic. So you can just if you're interested, you can go and directly plot also. So it looks something like this. So this is a straight line. Forgive my drawing. And these are your stationary points. So if you consider this as x-axis, as y-axis, this point where it attains the stationary point, this is your f of x plot. This is your x equal to 3, and it is all like flat at x equal to 0. So this is your origin, and at x equal to minus 1, again it has a minimum. So it looks something like this. Again, the drawing is not up to the scale. You can go and check. So yeah, so that is about this question. I hope it is clear. Just for the sake of clarity, I'll just mention the points here. It is 3 comma minus 10.25. It is 0 comma 1, and this point is minus 1 comma 0.417. So you can see how it looks. Okay, so we'll go to the next question now. Yeah, and this is the final question. So I'll have a water. 1 second. So this is a question based on the limit, and I have seen over so many years there is at least one question on limit in most of the gate papers, and this is like one of the area where you can score easy marks. Easy in the sense it's not straightforward, But if you prepare for this thoroughly, there is a very little chance that you'll go wrong in these type of questions. But anyway, let's see this limit. So we have to evaluate the limit. One second. So we have to evaluate this limit, and the limit is extends to 0, and you have a logarithmic function in the numerator and the quadratic x square at the bottom. So prima facie, if you put x equal to 0 in this limit, so this numerator becomes ln. One second. So numerator becomes ln 1 into cos of 0 divided by 0 square. So cos 0 is 1. So log of 1 is 0. So this becomes 0 by 0 form. So it's not a straightforward limit. Sometimes if you put the limit and you get non-zero value, that itself is the answer, but that is not so in this case. So you have to further look into this. So here you need to find, let's say I'll use some variable just to, because we have to evaluate something, right? So we can assign its value to, let's say, some random variable a, and the limit is extending to 0 ln 1 plus x square cos x divided by x square. So this is a 0 by 0 form. So in such cases, typically, if it is 0 by 0 or infinity by infinity or 0 by infinity, any of those combination, if it is there, then we have to use Hospital's rule, and which says that if the limit is of 0 by 0 or infinity by infinity form, or like that, not defined somewhere, then you take the derivative of numerator as well as denominator and then check the limit. If it is still 0 by 0 or infinity by infinity, then you have to further differentiate it till the point you get the finite limit. But in some strange cases, what happens, there are certain functions whose limit does not exist by definition. Uh, you'll not get those type of questions in GATE exam, but in general, I'm saying I have seen in some interviews, interviewer gives you a question where for that function the limit itself doesn't exist, and then the student keeps on differentiating it, and then the whole thing goes south. So uh, this L hospital rule, first we have to see if the limit exists or not. uh, there is a, theoretically you can try that, but it is out of the scope of this course, and we assume that there is a limit here. If we differentiate and then we realize after 2-3 differentiations also you're not getting the answer, then that is the point where you should realize that limit may actually not exist. There is no point in doing differentiation. So practically speaking, do differentiation 2-3 times and check whether you are getting any finite answer. If not, then the limit may not really exist also. So that is also case. So we'll go there. We'll start with the differentiation of both sides. So when you do that, you have limit extending to 0. So in the numerator, you'll need to use the chain rule because it's a composite function. So I'll just make it slightly spacious. So first differentiation of logarithmic function. So it will be 1 by x square cos x. Then according to chain rule, differentiate the inside, and here you have composite of composite. So you have 1 plus x square and then cos x. So that is UV form. So you have to do the UV differentiation here. So that will be, let's say you keep the first term as it is, then you differentiate the second one, which is cos derivative is minus sign. Then you keep the first or the other term as it is and differentiate the other one. So that will be 2x. So this is the complete derivative of the numerator. And in the denominator, it's straightforward. It is 2x. Now, before putting the values here, you can simplify this. What you can do is, you can, you know, multiply by this 1 by x square cos x factor into the square bracket at the numerator. And if you do that, what you get is, this 1 by x square cancels and you'll get minus sin x by cos x as one term. And then the second term is cos x and cos x gets cancelled. Second term is something like this. Okay, and the numerator is as it is 2x. Therefore, you can further simplify this. This becomes as tan x divided by 2x plus. So this we are separating the numerator also in the separate fraction. And this 2x will get cancelled in the second term and it will be 1 plus x square. So now we have simplified it. So it looks like our random variable a. It's not a variable, it's a random notation. Now we can get the limit inside the brackets. So there minus 1 by tan x by 2x plus limit extends to 0 1 by 1 plus x square. Okay, so this value, if you put x equal to 0, it is 1. And here you can further simplify it. You can take minus 1 by 2 common because it's a constant, and then you can put the limit extending to 0 tan x by x. And we know it's a standard result that this value is 1. So tan x by x or sin x by x, when x tends to 0, that limit is 1. That's a standard. And if you are not convinced, you apply L'Hospital to this fraction also, because it is 0 by 0. Then tan derivative is secant square x and x is 1. So it will be secant square x by 1. And secant square x will be 1. So 1 by 1 it is 1. So therefore it is 1. Therefore your a will be minus 1 by 2 plus 1. And therefore a will be 1 by 2. And this is your answer. Okay, so I hope it was not difficult to follow. Then, yeah, I think we have covered most of the questions from this calculus and optimization area. And we are at the end of this session. So, if you want to, learn more concepts like this, more subjects like this, you can always contact on this number which is given in this slide. You can also drop an email to the email ID mentioned here, and you can check out the various offerings by the institute at this website. And it will definitely help you in your preparation. So please do that. And yeah, this is the concluding slide of this talk. And thank you for your attention and time. And please follow and subscribe on various social media platforms mentioned here, so that this content reaches to more students here, and they also get benefited from this. And with that, I think we'll stop here for today. And uh, is there anything else, Dinesh sir, or should I end the meeting for all?